Smart scheduling is having the materials you need next arrive just before you need them, and not too early that they get in the way. The frames arrived at the perfect time. I had most of the floor complete, and the frames were placed exactly where I needed them. And once the floor was completed, we were ready to stand the frames. Or so I thought. The day the frames arrived, something else significant happened. New Zealand initiated its first response to the growing global pandemic. The introduction of the tiered alert system, and a few days later, a full lockdown was announced. I was lucky. If the announcement had come later, we would have stood the frames, and they would have been exposed for a much longer duration than I would have liked. All we could do now was cover the floor and the frames with plastic, and head home into the unknown. And 5 weeks later, we were back. The return to site was slow. Suppliers had to adapt to the new non-contact purchasing arrangements, so what was a return to work was still a week's delay for many. We had the frames on site, so we could kick off immediately. The back-to-work arrangements had conditions. One of them was keeping within work bubbles. So it was just me and my new offsider on site. It was very unlikely COVID would spread in our area. In fact, it took 2 years for that to happen. But the protocols everywhere meant that if you had any symptoms, there were things you couldn't do and places you couldn't go. We had a baby due in a few weeks, so the slightest sniffle or niggly cough would stop me from being allowed into the hospital. So I applied strict adherence to the rules on my site. Another protocol was that only one trade was allowed on site at a time. This was to keep the bubbles from overlapping. The drain layer wanted to get his team underway and reached out if they could schedule in early, because this project was easier for them logistically and material-wise to start on. So we stood the first lot of frames, then left it to them for a day. The other rule, it wasn't pandemic related, but seems to always apply in building. It rains when you don't want it to, and usually it's right after you've stood the frames. We'd had a long stretch of sunshine and warm days during lockdown, but now it was the change of season and an increase in rain frequency. We pushed on and took it in our stride, but I could see we had entered a phase of ongoing frustrating micro delays that would compound over the course of the project. I had to remain grateful though. I had work lined up for the foreseeable future, and most materials were able to be ordered and delivered within schedule, just with an adjustment for longer lead times. Looking back now, I'm reminded how lucky I actually was to be positioned well. The frames were on site ready to go, we hadn't stood them days earlier, and the build was able to progress and wasn't cancelled. I still had to deal with the usual issues that arise, like some of these frames being built wrong, and this is where I'll move on from my intro monologue about a time that feels like yesterday, but was actually 6 years ago. We're building a 76 square metre house in New Zealand, and there are some issues with the Prenail frames. But to the Prenail company's credit, they responded well and will deliver a replacement, which highlights an important quality I look for in a supplier or a subtrade. When they make a mistake, they own it quickly and work on a solution. The middle wall frame was built too low, and rather than come and rebuild it on site, which would have created a delay for me with the no other trades on site rule, they built and supplied us with a whole new frame, a practical and straightforward solution that considered the environment we were in. Once the majority of the walls were standing, we could assemble the larger window and door openings. The front wall was a bit piecemeal. I'm actually surprised it wasn't tagged by council as needing specific engineering design. Because it wasn't, It became Prenail's problem to solve. The large door lintel had a point load transferring down from the roof beam. Perhaps the designer had it covered. I wasn't involved in the design process, but the Prenail detailer decided another laminated beam running the whole width of the wall was a needed addition as a stiffener for the wall, so it didn't just fold in the middle when the wind blew. Based on the plans, he wasn't sure how the raking windows were going to work though, so he just supplied some raking frames that made up the rough shape and left that one to us. I'll go into more detail on the problem solving we did with these raking frames in a later episode. Before installing the stiffener beam, we did some straightening and plumbing of the frames, and this is a good time to do a quality assurance check. It's important to check each frame is in the correct position and that they are orientated the right way around and that the openings are where they need to be. When we initially stand the frames, I brace them roughly plumb to temporarily support them, and once they're all standing and in the correct location, I start the next step, which is locking in the bottom plates. I fix the plates parallel and square to my reference lines which I transferred onto the floor. These lines are from my original setout and profiles.
Same here. So we do the parallel.
I can also use a string line attached to each end of the plates, or corner to corner on a long run of walls. For shorter walls, a straight edge works too. I like to lock in the exterior walls first, and as I progress through, I nail the bottom plates together. 2 nails angled down through the top and a skew nail through each side. On a timber floor, you want the wall in the right place first, in case you nail into the floor and can't figure out why the wall won't move.
Still doing it?
Once the bottom plates are fixed, I fix off the top plate joins. An important step here is making sure the top plates are the same distance apart as the bottom plates. This is so that when the corner is plumb, all the walls in that line should move into plumb as well. Bottom and top plate joins need to be tight. A few millimeters gap over a few joins can put your walls out of plumb. Pulling them together can be done a few ways. I used a clamp here, but long screws can pull them together too, and there are various other tools that can lever them together. Invest in what works for you. Once the bottom and top plates were secured, I had the frames where I wanted them, which was important because I was about to cut an expensive laminated beam to fit into the front wall. This is the full-length stiffener that will reduce the flex that would happen because the larger lintel butts into the studs at the middle of the wall.
Not so good.
We set the raking window frames in place and then worked on plumbing the corners and straightening the top plates. The next phase of wall framing is to plumb the walls, starting with the external corners. If I fix the top plates in the right place, the intermediate walls along the exterior wall line should automatically move into plumb. The next step is to straighten the top plate along the perimeter. This is done with braces on the return walls first, to push or pull the top plate in or out. Once this is done, any internal walls that still require it are plumbed and braced. Then the longer runs of top plates are straightened with the intermediate bracing. I prefer to leave all of these braces on as long as practical, which usually means they're removed once exterior or interior wall linings are being installed, which take over for the permanent bracing requirements. When all of this plumbing and straightening work is complete, we should have a structure that's square, plumb, and straight. There are official guides to tolerances to follow, but I prefer to build my framing to the millimetre. It's not difficult to do when you follow a process. Timber moves, but that's where the tolerances can become the buffer. It's important because if my walls are 10mm out of plumb and another 5mm is added with plasterboard and plaster joins, what tolerance does the joiner have to work with when installing a kitchen? Their tolerances are usually far less than framing tolerances. It's always best to be accurate at every stage, so you save unnecessary work for the next person. These are top plate packers. We use a double top plate because the packer makes up the space for the ceiling battens and ceiling lining below the roof framing, while the first top plate is fixing for the top of the wall linings. I prefer to use 90x45 as an alternative to the wider 35mm thick boards, which overhang and act as a fixing for the ceiling linings around the perimeter of the room and fixing for the ends of the timber ceiling battens. I'm going to be using metal ceiling battens, which have a metal perimeter channel that fixes to the face of the 90x45 packer. Prenail frames and trusses are engineered and designed to comply with the building code. They're an alternative to building your own frames using the tables straight out of NZS 3604. This means every piece of factory supplied hardware must be installed as they've detailed it on the plans they send you to satisfy their producer statement. The nail plates have been specified for joining the top plates together and achieve a 6 kN connection. If you're not using Prenail frames, an alternative that also meets the same 6 kN requirement in NZS 3604 for joining inline top plates is to stagger the top plate and top plate packer joins. It's habit for me to install my top plate packers like this anyway, so at this point I'm just adding to and exceeding the strength required for the joins. But there's still an important structural job that the packer is doing. In some cases, the top plate packer continues across openings and gaps in walls to maintain a continuous load bar, from external wall to external wall, tying the structural bracing lines together. This ensures opposite sides of the building move together when resisting wind and earthquake pressures. If this wasn't done, a racking differential would occur between isolated wall sections, causing the walls to balloon out or collapse inward and lead to structural failure. That completes the wall framing stage and prepares us for the installation of trusses and rafters. Thank you for watching and following this build. I appreciate you all, and I'm really enjoying producing this series as I prepare for my own house build project.